All hail the Imperial Guard. That's right. This is for the AP Chemistry Summer Work Review for the exam you're taking on day number 1. Congratulations that you are part of the Imperial Guard. The Imperial Guard existed in real life. They were the elite of Napoleon Bonaparte's troops. And as you can see, this is part of what they had, their battle honors. And then, of course, one of the first rules of AP Chemistry, there is no crying in AP Chemistry. The second thing you got to understand is APUSH is a vacation in that it doesn't have the math that we have in AP Chemistry. Okay, I think it's about time that we got down to the serious stuff, right? And for that, time to get the old helmet on. And here we go, in case you're wondering, this is the British 7th Armored t-shirt that I have. So let's get this thing going. So in looking at the AP review here, we're emphasizing really on stoichiometry. The idea behind you guys knowing formula names like sulfate, sulfide, nitrate, nitrite. This is really to help you guys on the exam ultimately, because that is the goal of the class, is to get you guys ready for that exam, which it occurs in May, typically. So we're going to go ahead, and what I'm doing, I'm emailing you, if I haven't done it already, I'm emailing you the review questions that I have. It's going to be very, very similar to the test. So this should be a really big help in there. Okay, and of course, if you still have questions, you can feel free to email me. All right, so number 1, calculate the number of atoms in 3 times 10 to the minus 5th grams of gold. Okay, so what we do, first off, we look at how we number this. So notice I say 3e to the minus 5th instead of saying 3 times 10 to the minus. 3e to the minus 5th, you find that on your TI 85 calculators, the 83, the 84, and those. Okay, so I just do it for simplicity's sake. So we know that it's this many grams of gold. So the question is how many atoms are there? Well, here's the thing. This is where we have to talk about something called the mole. The mole is a number. You might remember that. Now remember, 1 mole is equal to 6.022 e to the 23rd atoms. Okay? Now, if it were a mole of water molecules, it's going to be this number of molecules. Now, a mole of anything is going to weigh something. And we know that 1 mole of gold has got to weigh this, definitely more than this. Okay, so we know that this number is not going to match this. This number is going to be a lot smaller. Okay, so the thing is, how many grams in gold are in 1 mole of gold? That's the question. Okay, so with that, we need to take a look at the periodic table. And you may look at the periodic table here, and let's see if I can kick it up a little bit higher. And if you look here, we can look at AU, there's gold right there, and it's 196.97. Okay, so now we have another piece of information. 196.97 grams to 1 mole of AU. So this is our basic information that we have. The question now comes down to is, how do we work with this? How do we go and find this out? Well, we know that we have to find out, okay, how much of a mole do we have with that many grams that we have here? Because we know it's going to be definitely less than 1 mole, right? Because you're looking at about 197 grams here. It's less than 1 mole. This is so much less than a mole. So we have to figure out, we got to change this into moles. We have, remember, a mole is a number. So we got to change this to moles. Okay? So how do we go about doing this? So we're going to change the grams into moles. Okay? So how do we do this? Well, it's going to be 3 e to the minus 5th, okay? And you can go ahead and divide it by 196.97 grams per mole. And this is grams. This is a fast way to do this. If you want to do the annotated bridge, you could also do that. Okay, so I'll go ahead. I'm not going to go ahead and show you this, but you know that you can divide it, and what you will walk away with is 1.5 e to the minus 7th moles of gold. Okay, now remember, a mole is like a chemist's dozen. Okay, that being said, ladies and gentlemen, a mole is like a chemist's dozen. Therefore, this is going to be, we can get a number out of this, can't we? All right, so how do we do that? Well, we know that there is 6.022 e to the 23rd atoms to 1 mole, correct? We know that. And what we're going to do, we're going to multiply by the 1.5 e to the minus 7th moles of gold over 1. Now, why in the world am I multiplying this? Well, keep in mind, the idea is that the moles will cancel each other out, and I will be left with atoms. So at the end of it, I'm going to have 6.022 e to the 23rd multiplied by 1.5 e to the minus 7th. And that's going to get us our final answer, 9.03 e to the 16th gold atoms. And with that, ladies and gentlemen, we are down 1 problem, but let's take a quick look here. We'll go back to the Zoom. So we calculate the number of atoms in this many grams of gold, very tiny. We know this is how many grams of gold we have, so we had to change that from mass of atoms to number of atoms. How in the world do we do that? Well, 1 mole is this many atoms. It's Avo's number. So how many grams are in 1 mole of gold? Well, we went to the periodic table. We found that out right here, 196.97, and then we changed it from grams to moles. So we divided the grams we had by the moles, grams per mole. That's how many moles of AU we have. It's to the negative 7th, so it's going to be a very small number. And then we multiplied it by how many atoms there are in a mole of anything, and that's how we walked away with 9.03 e to the 16th, or 9.03 times 10 to the 16th. Now, if you want to go times 10 to the 16th, that's perfectly fine by me. I have no problem with that. Okay? All right. Any questions? Gotcha! I'm on a video. Ha! All right, let's move on here. So let's take a look at the next one. Oh, sorry. There we go. So what is the mass of 1 molecule of canutil? CaNu. Wordplay on my last name. Who would have thought? But anyways, so in order to do that, we need, step 1, find the grams per mole of CaNu. We have to find it. Now, is this a real name of a real chemical? No, I'm making this up. And I thought, hey, I'm going to have some fun with this. So how do I go about finding the grams per mole? Well, again, I'm going to go to my periodic chart. I have calcium 40.08, nitrogen 14.01, and uranium at 238.03. So we can go back and we can add those up, which I already did here. So we're going to have 40.08 plus 14.01 plus 238.03, and that's going to get us 292.12 grams per mole of canutil. Okay? That's what we have. So that's how many grams there are in a mole. Now, here's the thing. How many molecules are in the mass of 1 mole of this. Okay, because now we know how many grams there are in a mole. Now we can take that and say, okay, I want to find out how many grams that one molecule of this will weigh. So in this case, we're going to need all those numbers, right? Because that's how many molecules there are in a mole. So as I say, 292.12 grams to 1 mole. So this is what I'm going to do here. And I need to change this to grams, okay, to 1 atom. Well, here's the thing. We're going to go ahead and we'll multiply it by 1 mole, right? It's going to be 1 mole. And in this case here, we're looking at 6.022 e to the 23rd molecules of Canutil. This is what we have here. So with that, ladies and gentlemen, now with this, we have our mass of 1 mole of this stuff. We're going to divide it by how many molecules are in 1 mole. And at the end of the day, boys and girls, what we are going to walk away with is, 4.85 e to the minus 22 grams to 1 molecule of Canutil. And that, ladies and gentlemen, is our final answer for this. Okay? So, again, you go back. We'll just take a quick overview. All right, we're looking at the mass of 1 molecule, so we need to find how many grams there were in a mole, look up that information on the periodic chart. We got that. Then we needed to know, we needed to take that mass of 1 mole of this stuff and divide it by how many molecules there are in that 1 mole. That's really what it is. Yes, we're multiplying across here, but ultimately you are dividing it. So you walk away with 4.85 e to the minus 22 grams per molecule. And that's it. We're going to move right along here. So, now the next question is, well, what is the percent nitrogen by mass in Canutil? Now, in this case, when we're looking at percent composition of something, we have to assume 1 mole of the stuff. It makes it so much simpler to say 1 mole. We say, well, why couldn't you do less than 1 mole or more than 1 mole? Too much of a hassle. Stick to 1 mole, and that will give you your percent composition, because remember, the idea behind percent, guys, the idea behind percent is part over whole times 100. That's our percent. Remember, guys, this is not regular chemistry. This is not honors chemistry. I would expect you guys to know this like the back of your hand on this one here, okay? All right. So we already know, based off of our previous problem, but I'm going to go through it again. We need to figure out how much 1 mole of the stuff weighs. And I go back to my periodic chart here, and I look that up. And to keep it simple, I got 40.08, that's for our calcium, plus 14.01, that's for our nitrogen, and plus 238.03, that's for our uranium. So the bottom line is we have 292.12 grams per mole of Canutil, okay? That's what we have. And with that, ladies and gentlemen, now we can figure out the percentage by mass of the nitrogen, because it will be the part over the whole. Well, what's our part? Our part is right here. It's going to be 14.01 over 292.12. Well, in this case, we don't really have to worry about our units, right? We don't. We don't. So I wouldn't even worry about the units in this case, because all you're interested in ultimately is a unitless number. Okay? And with that, ladies and gentlemen, we can get 4.80%. Okay. And with that, ladies and gentlemen, when we look at over here, oops, yeah, 4.80%. Yep. Okay, and that's it, 4.80%. That's it. That's it for that problem. Okay, let's go back. We'll review again. So we look, percent of nitrogen by mass in Canutil, part over whole times 100. So we figured out what our whole is. We added those up. So this is what we got. And then we took our part, our nitrogen, divided by the whole times 100, and we get 4.8%. So we'll go with it. With that, we're going to move on here. Now, this is a little bit more of a challenge. Which of the following samples contains the smallest number of atoms? 3 grams of O3, 3 grams of H2, 3 grams of O2, or 3 grams of Cl2? Ooh. Yeah, tough, isn't it? Well, how do we go about solving a problem like this? I gotta get a drink. In fact, I'm gonna take a longer drink. I'm gonna stop here for a moment. Pause! And we're back. Okay, so with that, guys, which of the following samples contains the smallest number of atoms? Now, you cannot tell just by looking, all right? Although there is something you do need to look at here, we got to figure out how many of each do we have. In other words, we got to figure out how many moles of each do we have. Okay? So, let's go with it. For the number of moles here, so it's 16 grams per mole here. It's going to be 3 grams divided by 48 grams per mole of O3. Over here, it's going to be 3 grams of H2 divided by 2.02 grams per mole of H2. And then we have 3 grams of O2 over 32 grams per mole of O2. And then the last one is 3 grams of Cl2 divided by 70.9, because the chlorine is 35.45 grams per mole of Cl2. So, and we got to figure out how many moles we have of each. That just makes it a little bit simpler. Okay? And you take the number of grams divided by the number of grams per mole. You know you've got definitely less than a mole of the stuff. Okay? So we're going to have 0.0625, 1.49, 0.094, 0.094, and then 0.042. Okay, so now that you have this, now you've figured out the number of moles each has, when you sit there and you're looking, you can clearly eliminate this one. You could clearly eliminate it because it is the biggest one. Okay? That's not going to work. This is also a pretty big number, and you've got 3 oxygens attached to it, not 2. So we can eliminate that, which is part of the process, which now leads us to here and here. Now, if you notice here, this one is clearly more than twice whatever this is. So this one has to be eliminated. So then you are left with this as the final answer. So our final answer, ladies and gentlemen, is Cl2. That's it. Okay? Pretty straightforward on this one. It's not always that easily straightforward, but you guys get the idea here. 3 grams over 48 grams per mole, because I got 3 oxygens, 3 grams over 2.02 grams per mole, because I got 2 hydrogens, 3 grams over 32 grams per mole of O2, because I got 2 oxygens, 3 grams, divided by 70.9 grams per mole of Cl2, because I got 2 Cls. Each Cl is 35.45. Okay? So with that, let us move on to the next one. All right, so E. Which of the following is not an empirical formula? This is a question of knowing the difference between empirical and molecular. Okay? So when you're looking at empirical versus molecular, ladies and gentlemen, there is definitely a difference here. Okay, empirical, lowest ratio, smallest number. Here, it's a bigger ratio. In other words, with molecular, you should be able to take the numbers and divide them out further. So let's look at H2O. Is H2O molecular or is it empirical? Well, the reality is, guys, you cannot break it down any further. So it's not molecular. This would be empirical. But we're looking for something that's not empirical. That's out. NH4, we can't break it down any further. How about C3H8? We can't break those down any further. Yeah, you could divide 3 divided by 3 is 1, and 8 divided by 3 is 2.66666667. But remember, in Chem, we really need the whole numbers as a rule. We do. We absolutely do. So that's out. Which means that our C4H12 is our molecular formula. It is not empirical, because we can break this down even further and say, okay, divide both sides by 4, and you'd get a CH3. This is empirical, this is molecular. That's the difference for it. Okay? All right, any questions on this? All righty, let's move on. Okay. This one is another multiple choice question. It's an organic compound which has the formula CHO and has a molar mass of 58. Okay, so we know the empirical formula is CHO, otherwise known as CHO. Okay? So what does that mean? That means that the formula, it could be C2H2O2, it could be C3H3O3, it could be C8H8O8. It could be. But we don't know. But they did give us something. They said it has a molar mass of 58. Now remember, a molar mass is grams per mole, right? So how do we start with this? Where do we even begin? Well, remember, we need to find out what's the molar mass of CHO to start with. Let's go with the basics, okay? Because what this should be at the empirical formula should be a multiple of this. Let's see. I go over to my chart. I know that my H is 1.01. My oxygen is 16 and the carbon is 12.01. I know that from my chart. So let's go with it. So I know that 12.01, 1.01, and 16.00. 29.02 grams per mole of CHO. Now, look at that 58, look at the 29.2. This is one of those things, remember in chemistry, that 0.02 isn't really going to make a difference, because remember, those numbers that we find on here, those are averages, because that also takes into account all the isotopes and how many of each kind of isotope that we would have. That's why hydrogen is not 1.00 evenly, because you do have a variant, an isotope of hydrogen that has a neutron connected with a proton, so it weighs more. But there's very, very, very few of them in existence, but they are out there. Okay? They call it deuterium. All right? So with this, guys, I'm going to sit there and think, okay, I'm going to take it as 29, so 58 divided by 29 is going to give me 2. So that means this is equal to X, which means it's C2H2O2. Because our original empirical formula was CHO. But when you multiply by 2, you get C2H2O2. And therefore, guys, question B is in fact our answer. Yep. Alrighty. Any questions on this one? Okay, awesome. Awesome. Let me check my thing here. And yeah, this is going to be a biggie. This is going to require a few steps for us, and that's okay. Because I believe this is, in fact, our last problem. Look, if you understand these problems, you are going to do so well on the exam. I am not worried about the names of the chemists. I am not going to be looking at the vocabulary. I'm going to be looking at your problem-solving skills for the test. Okay? So you have that. You're going to have the review. I'm going to email you the questions so you have it. And this video is showing you how to go about solving those problems. And that should put you well on the road to the awesomeness in the Imperial Guard. Okay. So we have a compound that consists of the following elements by weight percent. What do we mean by weight percent? In other words, we have a mass of this chemical compound and we've analyzed it. Of this mass, 25.5% is carbon, 68.1% is oxygen, and 6.4% of hydrogen. Okay, pretty straightforward for the composition. Now, the ratio of carbon, oxygen, hydrogen in the empirical formula is, this is where we have to start. So, where do we go about this? Well, you know what? The first thing I'm going to assume, and on your test you would actually be able to write on the paper itself, just letting you guys know, I'm going to assume 100 grams. Okay? I would assume 100 grams of the material. How come? Because they gave me the percent. It doesn't matter if I have 1,500 grams or 2 grams of it. If I got, you're still going to have the same composition, right? So I'm going to make it simple for myself and say I got 100 grams, which means that in carbon I have 25 point, whoops, let me erase this because this does not look right. 25.5 grams of carbon, okay? I have 68.1 grams of oxygen. And for hydrogen, I have 6.4 grams of hydrogen. So this is what I've got. What do I do? Now that I have this, I'm going to change them from mass into numbers because that's the only way we're going to be able to compare the ratio, aren't we? Do you guys see that? It's the only way we're going to be able to get a ratio of numbers to compare. We have to go from mass to numbers. Well, what is that going to involve? We got to change it to moles. Wait, do we need to change it to the number of atoms? No. We can change it to moles. Well, why do we need to change it to moles? Well, remember, a mole is a chemist's dozen. We can work with that. And it's a whole lot easier than deal with 6.022 times 10 to the 20. I'm not asking you how many atoms there are of carbon and of oxygen and of hydrogen. I'm asking what's the ratio of carbon to hydrogen to oxygen in our chemical compound here. See, that's the idea. So let's look at this. I'm going to change these to moles. So now we have, so our second step, we're going to change to moles. Okay? That's what we're going to do. We're going to change it to moles, ladies and gentlemen. And again, we go back to our friend, the periodic table. We can look at hydrogen, 1.01. We can look at carbon, 12.01, and oxygen, 16.0. We go back here, and I'm going to say we're going to go from grams to moles. Well, that means we're going to have to divide, aren't we? Yep, we're going to have to divide. So 25.5 grams over 12.01 grams per mole. We're going to have 68.1 grams over 16 grams per mole. And then we're going to have 6.4 grams over 1.01 grams per mole, because I was thinking H2 there for a moment. Nope, we're just looking at our entire ratio here. So now that we've got this, now that we have this, we're going to go ahead and we're going to divide this out. So what are we going to get? So for our carbon, we're going to have 2.12. That's our ratio of carbon that we have. For our oxygen, we're going to have 4.26. And for our hydrogen, we're going to have 6.37. So those are our mole to mole ratios of everything. Now, of course, guys, our formula now says C 2.12, O 4.26, and H 6.37. This is not going to work. That means we got to be able to reduce that down. We got to reduce those ratios down. How do we do this? Okay. Well, we're going to take the smallest number and we're going to divide it by itself. So we can make this a 1. So we're going to go ahead and divide everything out by 2.12. Because it's the smallest number and we can reduce that to 1, right? So that means for carbon, we're going to have a 1, right? For oxygen here, we're going to have a ratio of about 2. It's okay if it's a little bit more, if it's like 2.001, that's okay. We're looking at this. If it was like 1.98 or 1.99 or 2.01 or 2.02, it's a reasonable thing to say, okay, we can round it to 2. It's reasonable to do that. And then 6.37 divided by 2.12, that's going to get us an H of 3. So, at the end of the thing, our ratio, our final answer, ladies and gentlemen, is C1 to O of 2 to H of 3. And this, ladies and gentlemen, is our final answer. And that's it. This is the review, guys. This is what I have been working on for those people who could not make it to the review session, but you have it. And I'm going to email you guys the questions, and then I'm going to go over those with you and answer any questions that you might have. Okay. Hey, enjoy the rest of the summer. Remember, it's going to be an awesome year. Okay? All hail the Imperial Guard. Take care and God bless.